Okay, so stoichiometry, it's really like just this kind of mole band-aid that we stick on top of reactions. Okay, so we're taking everything we learned in the moles. Guess what? We get to convert from grams to moles. We get to convert from particles to moles. We get to convert from volume of a gas to moles. We get to convert from volume of a solution to moles, and volume of a solid, liquid, or gas to moles. And once you have found moles of substance A, did you guys understand what happened yesterday? Like you used to use the coefficients of the equation to go from moles of substance A to moles of substance B, okay? And we call that the mole ratio. And then once you have moles of substance B, you can find anything you want. Yes? You can find grams, you can find particles, volume of a gas, volume of a solution, concentration of the solution, volume of the solid, liquid, or gas, or the density. Okay, phew, right? Basically, if you sum it up, you're going to take whatever it is you know about substance A, whatever you're given in the question, and you will find moles of A. So you're always just finding moles of whatever's given to you, and then you convert it into moles of whatever you want to find out about, and then you convert back. Now, there are some little extras that we throw in at the end there, like what happens if you have an excess of one reactant, like you're going to have some left over, right? Because you don't always have perfect proportions, right? And so we'll look at that. But because this is kind of like I wrote this for, regular chemistry as well, we're probably just going to scream through this. Yes? Because if you understand how to do moles, then you basically understand how to do stoichiometry. Okay, the basic stuff anyway. So in 7b, so this is on page 9. We're going to be using our mole ratio. And I'm repeating myself again here. The key step in all these calculations, there should be an S in calculations there, is that in order to convert from substance A to substance B, you have to convert through the mole. So you'll see this little chart all through here. Okay, and the key is that you have that mole in the middle. Okay. So if I was to give you this equation here we have the combustion of propane. Could you solve the following problem? You know what, try it without looking at the answer. Like get yourself a piece of paper, cover up the answer, see if you can do it. Yes? Okay. So if you need some blank paper, there's blank paper at the back of the room. Okay, 3 blank paper right there. Help yourself as much as you want. I realize I make some mistakes. Did I have you do this for homework? No, this is it. Okay. Awesome. So just kind of give me a wave when you're done so I know that you're done. Oh, is that I'm done? Yep. Magnesium, copper, and zinc. My gray lines are going to be putting them in acid and seeing what happens. Yes. Yep. Not right today, but yeah. Well, maybe if we have time at the very end of class. Ooh, maybe if you all don't yell for a week, we could do that. How are we doing? Do you need more time? Do we need more time on this question? Yes? Okay. I will give you more time. No. I try not to eat at the cafeteria as much as possible because it makes me unhappy.
Very true.
Yeah. Why? Because it's disgusting. Because every entree seems to need to contain corn. Have you ever noticed that? Like everything that they serve contains corn. Like if you've got like, oh, it's a stir fry, oh, it's got corn in it. It's like, you know, chili, it's got corn in it. It's like, you know, chicken and rice, corn, like everything has corn. I don't. I just find it funny that that's like the staple of their, like we make fun of it in the staff room. Like we're like, is there corn in your food? There is. What's wrong with this meal? It has no corn in it. What? Why? Oh, we just find it funny that every meal that the cafeteria serves seems to have corn in it, right? Whether it seems relevant or not, they just throw corn in, right? Okay, so how are we doing? Do we need more time? No one is nodding at me. No one's saying, yes, I need more time. Okay. And we got what I got. Did I do it right? Oh, my answer's right. That's exciting. Now, what if you had to start with mass? Could you do that? Can you do the next one? Do the next one. Well, they started catching on that they were doing it wrong. So the new ones won't have color. Yeah. Well, if you would like to pay 5 times as much for your book, then yeah, you can have color. I know. What's up? What don't you remember? Hi. Oh, okay. We are on page 10.
Okay.
Yeah.
Did you do like a lesson?
We've not, I've just basically said, you guys can do this.
Okay.
I said, once you know the mole ratio, and did you understand the mole ratio?
Yeah.
Okay. Once you know that, I can give you mole, I can give you grams, I can give you particles, I can give you volume of solution, I can give you any of those things you used in that first unit, and you can find moles. Then you can use the mole ratio to find moles of the other unit. So the key is always to convert to moles first, and then use the mole ratio to get to your other substance, and then convert out into whatever you need. Let me know if you have questions. Okay?
No, I know who those are. Wait, I know who those are. You're in track.
Yeah, you just go on and do the exercises. So, are we wanting more practice on math, or are we ready to move on to volume? Volume? Do one question. Okay, do one more question on math, and then we'll move on to volume. One more question on math. Or you can do the example, or you can do one more question. I'm not. For someone else. Not a bad teacher. I'm not a bad teacher. All right. Yeah. You are not. No, hey, no, that came out of my mouth wrong. I didn't think that's not a good thing. Yeah. That came out with my brain wrong. See, that's all I understood. Hey, yo.
I really don't want to go scary. Oh, that's like a major W. How did I? No, you're not. No, no, she does not. No, don't compare her to that. Don't compare her to no, but look, what is you keep thinking? Wait.
In a silver oxide, like because it's CH8 written.
Oh, yeah, that's because I copied and pasted. Yeah, thank you. Alrighty, are we feeling ready to move on? Thumbs up, thumbs down, thumbs in the middle. Are we ready to move on? Okay, most of you are, so we'll do it. We'll come back to this, okay, as well. So this is on page 14. Okay, page 14. And we are still going to go with what? Not on page 14? It's near the bottom. Yeah, so this is the top of page 14. And we are going to use molarity as a conversion factor, because what is molarity? Molarity is moles over liters. That has to be given to you in the question. It's not a value you can look up anywhere. Okay, and again, just convert to moles of substance A, whatever you're given information about. Use the mole ratio to convert to substance B. Would you like to do an example with me, or would you like to do it on your own? With me? Excellent. So our first one we have is here. We have hydrogen gas is produced by the reaction of 118.5 milliliters of a 0.8775 molar solution of phosphoric acid. So we have 0.8775 moles per liter. Always useful to do that. Write it out with the moles on the top and the liters on the bottom. And it reacts with chromium. And the reason I gave you this reaction is because it looks a bit complicated, but now that I'm looking at it, I probably could have given it to you. What kind of reaction is that? It's a single replacement, so I could have just given you the reactants and expected you to, in theory, find the products. But here it is, and it's balanced. Isn't that lovely for us? So calculate the number of moles of H2 gas produced. What is our starting substance? What is substance A? What do we know stuff about? We know stuff about phosphoric acid. So we're going to take this information and we're going to use that to find, what will we find? Moles of H3PO4. Right? Because that's our phosphoric acid, right? So we have the milliliters of that, we have the moles of that, we can find moles of H3PO4. From moles of H3PO4, what would we then convert into? Yeah, we're asked about hydrogen gas, so we're going to convert to moles of H2, and at that point we're done, although if I said at STP, we could convert it to liters if we wanted to, okay? So let's do that. We have, and of course, milliliters. What should you be doing with milliliters if we're going to do a conversion using moles per liter? Convert it to liters, so that's 0.1185 liters. So we're going to take our 0.1185 liters of H3PO4. And one of the things I'm going to really encourage you to do when you're doing this unit is to write your substance, because we are changing substances halfway through. Yes? We're starting with one thing, we're finishing with another. So if you don't tell me which one I have liters of, I won't know, right? Is it liters of hydrogen? Is it liters of H3PO4? I won't know. And then we convert it into, let's see, we want to cancel liters and we want to find moles. 0.8775 moles per liter. And I should be writing, what should I be writing on the top? H3PO4. Otherwise it gets really complicated later. Once I have found moles of H3PO4, I want to find moles of H2. And when I'm converting from moles of one thing to moles of the other thing, what do I use? The mole ratio. And where do I get that from? Balanced equation. So my H2 has a 3 in front of it, and my H3PO4 has a 2 in front of it. So we have a 2 here and a 3 here. And it's a good thing that I only had that one conversion, because I ran out of room, and we get something. Where are all my calculators? Oh, they're all right in front of me. Look at that, a whole box of them. 0.1185 times 0.8775 times 3 divided by 2 is 0.155975. Woohoo! Do I want that many digits? No, of course not. How many digits do I want? 4. I've got 4 sig figs here, 4 sig figs here, so that's going to give us 0.15. Uh-oh. When I round that, it's going to become 156, and because I need 4 sig figs, it's going to become 1560. And my final unit, all I'm left with is moles of H2. Is good? Okay. Would you like me to do another example with you, or do you want to do the next one on your own? On your own? Excellent. Once you're done that, you can just keep working on these, and then when we've had a little break on that, we'll move on to the next one. Okay? What? Sure. Yeah, we're going to do whatever's on page 15. Is 15? Okay, 15 is the one that we just did. Don't do that one. How about the one on the next page? Yeah, page 16. Do page 16. You know what? It's never bad to keep guessing at them because that way you know you didn't have it this morning. But I didn't have to in the All reactions take place, okay? Hi.
Hey, Miss Sands, I heard that Mr. Anderson was looking for me. Oh, is Mr. Anderson, you were looking for Miss Lou?
Yes, I was. Awesome.
Sanford Toys looking for me. Oh, well, she's right here.
Awesome.
I was hiding over here, she's on the other side of the door.
So you could go and see her now.
I will go see you.
She's just in there.
You're not going to go back to work yet.
He brings a different vibe back to the class.
Oh, this is gonna be so fun. We gotta do balancing and we gotta do one balance. It's not bad. Just like solid. You're lame. Okay. Still older than me, that's I mean grade 11. Don't do it. Okay, I gotta write out the equation just so I don't screw it up. You make it sound like you have you make it sound like you have a disorder. Yeah, so of course we talk to her. They're friends. So I'm gonna
Okay, I actually didn't. I mean, it was part at first.
you know, you improvise, you go, you stand up, and you're like, yes,
Are we ready for the next one? No, not yet. One more question? Okay. Do one more question and then we'll start on the next one.
Hi, Mr. Ali. No, no, everyone on this side. Oh my God, yeah.
Are you coming to see who's all in here?
Yes.
Who comes to your class?
I know that dude.
Oh.
You can?
let's go, I got it. I got it. I'm amazing. It's probably like a lot longer than you did, but like, let's go. Sorry, I'm just. Oh, you dream. Oh yeah, I guess the way you could justify not being very social is that after I started talking to you, I talked to you a lot, even though I didn't really even thought. But to be fair, that's because I thought you Here's the easiest thing to do. Yeah, so like let's say you're in chem class, let's say you're next to the person talk about chemistry. trying to study for your online assessments. Maybe you could try I just explained to you. If you focus on the subject that you and then you will focus on that subject. And then you can learn more because these unless they're boring and they don't have any other fun, then don't talk to kids. Literally say you have, what do you mean? Play baseball.
When did I say your quiz was next week? Wednesday? Okay. Okay, now, I did want to let you know that there is some extra practice in the big black book. So, but that's online. If you want to sign out a physical copy and you do not yet have one, feel free. Okay. I will make a copy of table 8.4, which has the bond enthalpies in it, so that you don't have to like flip back and forth within the ebook. So I'll get that for you. And in fact, I could do that before you. Would you like a physical copy of it? That page? No? Yes? I'll make a physical copy. It's all good. Okay. Yes. I'll put the pages and everything on Teams. Okay. So there will be some BLB questions. There will be some Hebden questions. And then next week on Monday, I will have made the quiz and figured out exactly what I'm going to be asking you, and I'll try to give you some more questions that are kind of like directed that way. Okay? So these will be on Teams. Okay? Are we ready for 7.1D, or do we need another minute? Another minute? Or another 5 minutes? Okay. Or should I cut my losses and say you're doing enthalpy and these two over the weekend and just be done? Should we do that? Yes? Okay. So I'm saying we're done for like learning new stuff for the day, because that way you can practice the mass conversions, the mole volume conversions, and you can practice for this over the weekend. Yes? Yes. Yes. It is on Teams. So if you go to So if you go to our general files, so in the general channel in files, and you wait for the circle to go around many times, at least if you're at school you do, then you will see the big black book, BLB, okay? And there's also a worked answer key, okay? So they are just down at the bottom here. Okie dokie? Yeah. Everyone has a copy of Hebden at this point? Okay. Yes. 11 to 13.
So if there's a quiz on Wednesday, they're probably going on Friday, right?
No.
So there's a review for the BBB on Hebden,
And then do the, just finish the questions in the 2 sections we did today.
okay.
Yeah. So, folks, homework. I just want to be clear. So you're finishing off the 2 sections we did today, so you have lots of practice with that. Pages 11 to 13 and 18, and you are going to study for your quiz so that you'll be able to ask me questions on Monday, and then I can give you one final review, and then your quiz is on Wednesday. Wednesday. Yes. Not Thursday or Thursday.
I've never seen Ian ask. Oh yeah, okay. But like he wasn't like he didn't slip. That was